Hi mathematicians, this is Mr. M. One of the most versatile and fundamental algorithms for solving quadratic equations is known as completing the square method. Please assume that the quadratic equation is ax squared plus bx plus c equal to 0, in which a, b, c are constants and x is the variable. The graph of the related quadratic function f of x equal to ax squared plus bx plus c is a parabola with a y-intercept, an axis of symmetry, a vertex, and possibly x-intercepts. Completing the square method can be used to solve x squared plus bx plus c equal to 0. In this equation, the coefficient of x squared is equal to 1. This means that the constant a is also equal to 1. The first step is to move the constant c to the right side of the equation. The second step is adding the square of half of the coefficient of x to both sides of the equation. In this equation, observe that the coefficient of x is b. As such, add half of b, the whole thing squared, to both sides of the equation. The third step is to write the left side of the equation as a square trinomial. A square trinomial has the form x plus a, the whole thing squared, where simple a is a constant. The fourth step is to calculate the plus or minus square root of both sides of the equation and to solve it. Now, apply these steps to solve x squared minus 2x minus 3 equal to 0. Move the constant term, which is minus 3, to the right side of the equation. When minus 3 is taken to the right side of the equation, its sign changes to the opposite sign, and the equation becomes x squared minus 2x is equal to plus 3. The next step is to calculate the square of half of the coefficient of x. Here, the coefficient of x is minus 2. Therefore, half of the coefficient of x is half of minus 2, which is minus 1. Square minus 1 to get plus 1. Adding plus 1 to both sides of x squared minus 2x plus 1 will be equal to 3 plus 1 will be equal to 4. Now, the left side of the equation must be written as a square trinomial. Thus, x squared minus 2x plus 1 will be equal to x minus 1, the whole thing squared. This is because x minus 1, the whole thing squared, is equal to x minus 1 multiplied by x minus 1, which reduces to x squared minus 2x plus 1. Therefore, the equation is now written as x minus 1, the whole thing squared, is equal to 4. The next step is to take the plus or minus square root of both sides of the equation. Square root of x minus 1, the whole thing squared, is equal to x minus 1. And the plus or minus square root of 4 is equal to plus or minus 2. Therefore, x minus 1 becomes equal to plus or minus 2. Solving for x, you will find x equal to 1 plus or minus 2, which is equal to 1 plus 2 and 1 minus 2. If you crunch those numbers, you get 3 and minus 1. Here is a fun fact. Check out the x-intercepts of the related quadratic function y is equal to x squared minus 2x minus 3. Lo and behold, they're also 3 and minus 1. This proves that the graphical solution matches the solution by completing the square method. Now let's apply these steps to solve half of x squared plus 2x minus 1 equal to 0. When the coefficient of x squared is not equal to 1, multiply the entire equation by the reciprocal of the coefficient of x squared. In this instance, the coefficient of x squared is equal to half, which means that you must multiply the entire equation by the reciprocal of half, which is equal to 2. This results in the equation being written as x squared plus 4x minus 2 equal to 0. Now, apply the previous steps to solve the resulting equation. Move the constant term negative 2 to the right side of the equation. When negative 2 is taken to the right side of the equation, its sign changes to the opposite sign, and the equation becomes x squared plus 4x equal to plus 2. The next step is to calculate the square of half of the coefficient of x. Here, the coefficient of x is 4. Therefore, half of the coefficient of x is half of 4, which is 2. Square 2 to get 4. Adding 4 to both sides, x squared plus 4x plus 4 will equal 2 plus 4, which is equal to 6. Now, write the left side as a square trinomial. Thus, the equation becomes x plus 2 the whole thing squared equal to 6. Now take the plus or minus square root of both sides of the equation to find x plus 2 equal to plus or minus the square root of 6. But square root of 6 can be written as 2.449. Hence, solving for x, you'll find x equal to negative 2 plus or minus 2.449, which is equal to 0.449 and negative 4.449. Now take a look to the left at the x-intercepts of the related quadratic function y equal to half of x squared plus 2x minus 1. Do you think that the x-intercepts align with the roots of the quadratic equation found by completing the square method? This time, consider the equation 2/3 x squared minus 4x plus 7 equal to 0. Here also the coefficient of x squared is not equal to 1. As such, multiply the entire equation by the reciprocal of the coefficient of x squared. This results in the equation being x squared minus 6x plus 21 out of 2 equal to 0. Since 21 divided by 2 is equal to 10.5, the equation becomes x squared minus 6x plus 10.5 equal to 0. Move the constant term plus 10.5 to the right side of the equation to get x squared minus 6x equal to negative 10.5. Adding the square of half of the coefficient of x to both sides of the equation gives x squared minus 6x plus 9 equal to negative 10.5 plus 9, which in turn is equal to negative 1.5. Now, write the left side as a square trinomial. X minus 3, the whole thing squared, is equal to negative 1.5. Taking the plus or minus square root of both sides of the equation, x minus 3 would equal plus or minus the root of negative 1.5. Since the square root of a negative number is a complex number, plus or minus the root of negative 1.5 will equal plus or minus the root of 1.5 multiplied by the square root of negative 1, which is in fact equal to plus or minus 1.225i, where I represents the root of negative 1 and 1.225 is the square root of 1.5. Hence, solving for x, you will find x equal to 3 plus or minus 1.225i, which is in fact equal to 3 plus 1.225i and 3 minus 1.225i. Observe that both solutions are not real numbers, but are complex numbers. This agrees with the fact that the graph of the related quadratic function, which you can see on the left, does not intersect the x-axis. In closing, the algorithm to solve a quadratic equation in x by completing the square is broken into 5 general steps. First, if the coefficient of x squared is not equal to 1, multiply the entire equation by the reciprocal of the coefficient of x squared. This will make the coefficient of x squared equal to 1. Second, move the constant term to the right side of the equation. Third, add the square of half of the coefficient of x to both sides of the equation. Fourth, write the left side of the equation as a square trinomial. Fifth, take the square root of both sides of the equation and solve for x. That's it, guys. It was a pleasure presenting to you. Thanks for listening. Until we meet in another presentation, this is Mr. M. Over and out.